Hi there and welcome. We're going to be looking at section 4.5 today, the derivative of the natural log of x. So we're going to take our natural log and apply some calculus to it. So let's look at the rules for the derivatives of natural logarithms. The derivative of the natural log of x is just 1 over x, and this is only valid for x greater than 0. Now the derivative of the natural log of some function of x, just using the chain rule here, is going to be 1 over our function, or g of x, times the derivative of that function. So we're doing derivative of what's on the inside here. And when we get that, we're going to have just g prime over g of x. So our last property here is the derivative of the natural log of the absolute value of x, and that's still 1 over x, where x is not equal to 0. So we can extend this to negative values of x as long as we put in our absolute value symbols. So let's look at an example. We're going to take the derivative of the natural log of the quantity e to the 2x plus 1, and then that whole thing is squared. So that's our given expression. Now what we need to do is we need to take the derivative. Let's look deep inside. We have like a function inside a function inside a function here. So first up, I see that outside function is to the second power. So I'm going to take the derivative of that by bringing down the 2 and then leaving that inside function, the natural log of e to the 2x plus 1, leaving that alone, times the derivative of what's on the inside. So times the derivative of that inside function. Then I'll leave that first little bit alone, and I'm taking the derivative of the natural log of the quantity e to the 2x plus 1. And what I'll get is that u prime over u, or in other words, we'll get 1 over our function e to the 2x plus 1 times the derivative of that inside function. Taking the derivative of that inside function, we just get that 2e to the 2x, and we're not going to clean this up. We'll just leave it like this, and there are other things that we may end up having to do to it. So let's say we have a function where we have the natural log of x plus 1 over x. Now, this has a relative extreme point for x greater than 0. So we need to find the coordinates of that point. And is this a relative maximum point or not? So let's write our given function. We're going to use our quotient rule to take the derivative. So here we take our quotient rule, then we're going to simplify. We end up with f prime equals negative natural log of x over x squared. We'll set that derivative equal to 0. When we do that, the derivative will not equal 0 when the numerator equals 0 and the denominator does not equal 0. So that won't work for us. So 0 equals the natural log of x. We set the numerator equal to 0, writing that in exponential form. We have x equals e to the 0, which equals 1. To determine whether the function has a relative maximum at x equal 1, let's use the second derivative. So we take our derivative, which is negative natural log of x over x squared, and then we take the second derivative. Using the quotient rule again, we then get that f double prime is negative x plus 2x times the natural log of x all over x to the 4th. Now let's factor and cancel, and we get that f double prime is negative 1 plus 2 times the natural log of x all over x cubed. Now we need to find out what f double prime of 1 is at this point. So we're just going to plug in a 1, and we're going to evaluate, and we get that f double prime of 1 equals negative 1. Now, since the value of the second derivative is negative at x equal 1, the function is concave down at x equal 1. Therefore, since it's concave down, the function does indeed have a relative maximum at x equal 1. Now to find the y-coordinate of this point, we are just going to plug this into our regular function and get f of 1 equals 1. So the relative maximum occurs at 1, 1. And that's all we have for section 4.5. If you have any questions, you be sure and email me. Have a wonderful day.